Assalamualaikum, my name is Akil. Now I will explain the meaning of differentiation. Differentiation is a mathematical tool used to calculate the instantaneous rate of change of a function with respect to its variable. Geometrically, find the exact slope of a curve at any single given point.
Hello, my name is Danny. Today I will show the step-by-step solution for question 2. That is to find dx dy for any function using product rule and quotient rule. We learned that finding derivative using the first principle definition can be tedious. Instead, we use the technique of differentiation to find derivative more efficiently. I will use the product rule and the quotient rule to solve my two questions. For question A, the function is y equal to x squared times cos 3x. Since the two terms are multiplied together, we must use the product rule. Let's find u, u prime, v, and v prime. First, we set u equal to x squared. Differentiating this gives us u prime, that is 2x. Next, we set v equal to cos 3x. To find v prime, we differentiate the outside cosine to get negative sign, and then we multiply by the derivative of the inside angle, which is 3. This gives us v prime equal to negative 3 sin 3x. Now we put the value into the product rule formula, that is dy dx equal to u v prime plus v u prime. We get dy dx equal to x2 times negative 3 sin 3x plus cos 3x times 2x. Rearranging the terms give us our final answer, that is dy dx equal to negative 3x squared sin 3x plus 2x cos 3x. For question B, the function is a fraction. The function is y equal to exponent to x over x cubed. Since it is a fraction, we must use the quotient rule. We set the top as u, that is equal to exponent to x. To get u prime, we copy exponent to x and multiply by the derivative of the power, which is 2. This gives us u prime equal to 2 exponent to x. We set the bottom as v, that is equal to x cubed. Differentiating this gives us u prime, that is equal to 3x squared. We substitute this into the quotient rule formula, that is dy dx equal to v u prime minus u v prime over v squared. This gives us x cubed times 2 exponent to x minus exponent to x times 3x squared over x cubed squared, which become x to the power of 6. To simplify, we divided every term on top and bottom by x squared. This gives us our final simplified answer, that is dy dx equal to 2x exponent 2x minus 3 exponent 2x over x to the power of 4. That's all for me. Thank you.
Hi, move to question 3, which is my part. The question shows that we need to find dy dx for the equation using implicit differentiation. Before doing any calculus, let's make our life easier by simplifying the first term. Using log laws, we can bring the square root exponent forward as a half. 4 times a half is 2, so the terms simplify down perfectly to 2y power of 3 ln x. Now we differentiate term by term. For 2y power of 3 ln x, we must apply the product rule, keeping 2y power of 3 and differentiating ln x give 2y power of 3 over x. Then keeping ln x and differentiating 2y power of 3 gives 2y power of 2 ln x dy over dx. Don't forget the dy over dx because of the chain rule. Next, the derivative of a exponential power of 4x plus 5. For this, 32 exponential power of 4x plus 5 by multiplying by the inner derivative 4. Finally, the derivative of cotangent 6y gives us negative 6 cosecant power of 2 6y dy over dx. It's because of the chain rule. Okay, don't forget on the right side of equal sign, differentiating 3x power of 2 plus x minus 7 simply leaves us with 6x plus 1. Putting the entire puzzle together, we get our massive combined layout. Our final goal is to isolate dy over dx. Remove all terms that don't have a dy over dx, specifically the exponential terms and the fraction. Over the right side, changing their sign. On the left side, we factor out dy over dx from remaining components. To finish up, we divide the entire right side by that factor bracket. Arranging the numerator slightly match our clean final layout. We get our final answer is dy over dx equal to minus 32 exponential power of 4x plus 5 minus 2y power of 3x power of minus 1 times 6x plus 1 over 6y power of 2 ln x minus 6 cosecant power of 2 6y. That's all.
Hello everyone, I am Muhammad Azim bin Muhammad Asli and I will be the one explaining question 4. Question 4 states to use linear approximation to estimate the value of any equation correct to 3 decimal places. The equation you see here is the one I took from the calculus 1 to the workbook. Exercise 2.7, question 4. To begin, the formula for a linear approximation is this. So we first need to find x, x0 and delta x. X is the given number in equation, which is pi over 5 plus 0.05. Next, x0 is usually the closest whole number to x, but because there's pi in the equation, we can use the radian term for pi. So x0 is pi over 5. Or in radian terms, 60 degrees, which is the whole number. Lastly, delta x is the difference between x and x0, which is exactly 0.05. Next, we need to find fx, so we can find fx0 and f prime x0. To find fx, simply replace the given numbers in the equation with x, and we get sin x. Now we plug x0 into sin x. And we get 0.5878. For f prime x, simply differentiate fx, which makes sin x become cos x. Plus x0 into cos x, and we get cos pi over 5. And we get 0.8090. Finally, we plug everything into the formula and now we get 0.6283. But since the question asks for 3 decimal places, the final answer is 0.628. That's all.